Any questions on number 8, 9, or 11 that you could not figure out on your 1.2 homework? Any questions on number 8, 9, or 11 if you couldn't figure one out? Let me know and I will do one of those right now, maybe two if you can't figure them out. Put it in the chat or unmute yourself. Only one of those was a circuit. The other two were paths. Any requests? Number 8. Okay, now I was asking for number 8. So I'm going to blow up number 8 and show you one possible solution. There are many different solutions to this problem, but this was the one that had a circuit, and I will just show you one solution. This is not the only one, so if you got something that might have been different. I started here at D, and then you could have gone up to A as one move, then over to F, then over to E, and down over to B, and then across to C, and then back to D. So this is number 8. Go ahead, since I was able to start and end at the same vertex. Notice I didn't use every edge. I didn't need to. You only need to go to the vertices. So this, make sure you label it as a circuit for number 8. And if you can't draw it, some people are saying, I can't draw on the thing. Well, you can do two things. You can draw it on paper and you can email it to me, say, take a picture and email it to me. Or you can write the circuit, or write the sequence here. So I started at D, and then I went to A, and then I went to F, and then I went to E, and so on. So that's 2 different ways you can do it. If all else fails, if you guys are having technology problems or you can't get on a computer, write it on paper, take a picture of it, and email it to me. Somebody did that this morning. They were worried about getting in on time. Guys, I'm going to be flexible with you guys, okay? So there's just another way to do that. I'm going to leave this up for about 5 more seconds. Snap a picture, a screenshot of it if you need. But this is number 8. All right, does anybody need 9 or 11? They were just paths on those 2. There's a lot of different ways to do either one of those. Okay, what about the bottom? So number 12, 13, and 14. 9 confused me. 12. Okay, so let me go back to 9 real quick. So on number 9, there was no way to find a circuit on this one, but there are a couple different ways to do a path. So you could have started in a number of ones. Let's just say I started here at C. You can go up to A and then to B, and then from there you can go just to F, E, and then D. So I started at C, ended at D. I went to every vertex one time. Remember, this is Hamiltonian, so we don't have to go to every edge. But I used every vertex once. This is a path for number 9. Okay, does that help, Faith? You're probably thinking of Eulerian if you're unable to figure those out. Okay, number 12, Jill, you're gonna as soon as I tell you this, you're just gonna be like, oh my God, why couldn't I figure this out? What's a graph that has a Eulerian and a Hamiltonian? Remember that it's using every edge. You could super easily just draw like a square or a triangle. And this has to have a Eulerian and Hamiltonian. You just go around the outside. Did anybody else do that super simple, just like a square or a triangle or a pentagon? Any polygon will work. So that should have been pretty simple. What about 13 or 14? Anybody on 13 or 14 before we move on? So it's not letting you draw. Are you doing it on the computer or are you doing it on your phone? Oh, that's why. If you don't have access to a computer, yeah, just draw it on a piece of paper and then just email it to me. And take a picture and email it to me. Yeah. So number 13, draw a graph that has a Hamiltonian but not a Eulerian. So a graph that does not have a Eulerian, you just need to make sure that at least one of the vertices has an odd degree. Because remember, if every vertex has an even degree, then it does have a Eulerian. But if one of them is odd, it's not. So I'm going to just make a simple square, say. So right now, this has a Hamiltonian and a Eulerian circuit. Every vertex has a degree of 2. But if I draw this little line right here, now this vertex has a degree of 3, and this vertex has a degree of 3. So this possibly cannot have a Eulerian circuit. But I can still do a Hamiltonian just by going all the way around, just to get at every vertex. So that should be pretty straightforward. There's a solution there for number 13. Okay. All right. So there is your answer. Is anybody? Are you guys good with 14? Or do I need to do it? Okay. All right. So here's what we're going to do today, guys. We are going to break out into groups in just a minute, and I'm going to give you a problem to work on in groups. I really hope that this class participates very well with this. In order to do that, we're going to do, a real quick pair deck. I'm not going to take the whole time to do this today in class, but let's indulge me while you're here. And I'm going to put the link in the chat if you need to. Get logged into this because in a minute when I break out into groups, I am not going to share my screen anymore. And the only way to see the problem is if it's on your screen. So you can log in on your phone or you can log in on another tab, but get logged into this so that you can actually see the problem that we're going to work with. I'm going to give you guys about 1 minute to do that. So you should be able to get in pretty quickly. I'm waiting on a few of you guys. Okay, you guys have the link there, so I'm gonna go ahead and get started and show you what you guys are going to do. So we've talked about graphs. You know about Eulerian graphs using every edge. You know about Hamiltonian graphs using every vertex. We're going to add in one little thing to this problem, to graphs here, called weighted graphs. And I'm going to start out like I've started out with some of the other ones with a little problem that I want you to try to solve. And it's actually another classic logic problem. There is a solution to this. I'm not trying to trick you. It's called traveling salesperson problem. And here you can read this on the screen, but here's what you guys are going to do. In a minute, I'm going to blow up that map that you see there at the bottom. And that map has a 5 different cities on it, including Austin, and it has a flight between every city and the cost of that flight. And you're a traveling salesperson, and you're going to start from Austin. And for your job, you got to travel to each city next week to sell some stuff. And so your first flight, you're going to travel to one of those cities, either LA, Chicago, Atlanta, or New York. And you're going to do that on Monday. You're going to fly out on Monday. And on Tuesday, you're going to fly to a different city that you haven't gone to yet. On Wednesday, you're going to fly to a third city. On Thursday, you're going to fly to a fourth city. And then on Friday, you're going to fly back home to Austin. Okay? What you guys are going to try to do is you're going to try to find the least expensive route that begins in Austin, goes to the other cities at least once, and then comes back to Austin. Okay, I'm going to break you out into groups, and what I really want you guys to do, turn your cameras on, talk to each other. Even if you're trying to figure this out on your own screen, you may not come up with the lowest answer. You might find a route that costs like $2,800, and somebody else might find one that's $2,600, and then you're like, oh wait, guys, I found one that's $2,500. So you guys talk to each other about the different routes that you're taking. When I move to the next screen, because I'm going to stop sharing my screen here in a second. When I move to the next screen, it's going to show up a bigger version of the map, and it's going to let you drag some numbers, some little circle numbers, and say 1, 2, 3, 4, and 5. So that's just to help you guide you like which route you want to take. So put 1 on the first city you're going to go to, put 2 on the next city you'll go to, 3, 4, and then 5 will always go back to Austin because you got to come back home. All right, you live in Austin, you're coming back home to Austin. Okay, so I'm going to put you into breakout rooms. Please, please turn your camera on. Talk to each other as you guys work through this. I'm going to bounce around and see if you guys can come up with an answer. When you think you have an answer, add up the 5 numbers that are on those flights. So add them up, and I will tell you if you're right or wrong. There's only one lowest answer. Okay, I'll tell you whether you're right or wrong. When the first group that can do it, we'll have some candy waiting for them next week when you guys, if you come back to school. If you don't, sorry. Maybe I'll mail it to you. I don't know. All right. You guys ready? Let's see. Oops. Why did this not work? All right. Join your room. Crap. Please tell me you didn't see that. I accidentally went 2 slides ahead and it showed the solution for like a brief second. Do you guys know what to do? Okay. I'll come back if you come up with a solution. Please tell me you guys didn't see that. Do you know what I'm talking about? Okay, good. I accidentally went 2 slides ahead on the screen and it showed the solution for like a split second. No, you gotta work on it. Do y'all know what to do? Okay, turn your cameras on first. Hold on. So I'm not talking to a black screen. So those little numbers on your screen are just to help guide you which cities you want to go to in that order. Okay? So you're starting in Austin. You got to fly to every other city one time and you got to come back to Austin. So that's 5 total flights. Okay? And you're going to try to do it in the lowest possible price. So try to find the way to the lowest possible price in order to do that. The numbers there on the screen are just to help you to guide which order you want to go in. And if it doesn't work, if you find something lower, then change it. Okay? That makes sense now, Mia? All right. The rest of you could turn your screens on too. All right. You guys know what to do? I mean, your cameras are all off. You're not talking to each other. Anybody? Bueller? Bueller? I hate talking to a black screen. Okay, so y'all talk to each other, guys. Jasmine, you had your camera on a minute ago. Tony, guys, y'all help each other out. I'll be back to see if you guys have come up with a solution. Remember to add up the total cost. All right, you guys know what to do? Are y'all even talking to each other? Come on, guys. If you guys type in the chat, everybody's gonna see it. So just FYI. Did you listen to what I said? You're gonna start in Austin. You're gonna fly to another city. Add that price. Then you're gonna fly to the next city that you haven't been to. Add that price, and so on. But you got to fly back to Austin at the very end. Those numbers on the screen are just to help you drag so you can follow your order. Okay. Y'all come up and y'all look at different options and see if you can do it in the lowest possible price. Once you have it, once you think you have the lowest price, talk to each other about it, and then I'm going to come back and see if you're right. Okay. Think you have a solution yet? Don't put it don't put it in the chat because everybody will see it. Yes. So you got to add that last flight. You'll have a number? Or no, not yet. Claudia, Adria, y'all there? Okay. All right, I'll be back. Do you guys have a answer? What did you come up with? Did you talk to everybody else about it? Zach, Gustavo, Miranda, are y'all there? Okay. What are the numbers that you came up with? Anything? Yeah, the total. Hmm. What was yours, Nyla? You there, Nyla? Okay. Y'all see if you can agree on that number. It's the group with no cameras. Melody, Anthony, Tony, are y'all there? Do you guys have a number? Have y'all come up with a number yet? You can't come up with one? Like, come on. I'll be back. You guys think you have a number at all yet? Any solution? Adrian, are you there? Don't don't put it in the chat because everybody can see it. What number did you come up with, Faith? 45? Okay. I think you probably just typed in something wrong, but that's correct. The answer is 2004-55. Yeah. Jose, is that what you got too? Okay. Good job, y'all. Y'all are the first group to get it. So I'll let me hang tight a few minutes. All right, we have two groups have already gotten it. Let's see if you guys have figured it out. Give me an answer. As anybody else have that? 2075? Did you make sure to come back to Austin? That's not possible. Check it again. Yeah, I'm sure. Tell me what it is. Tell me where'd you go. Wait, but you had to start in Austin, remember? Yeah, there you go. Adri's right. Adri, the one you had was right. Good job. Hey, while I'm waiting, tell everybody else the route that you did, okay? All right, guys. Three groups have figured this out. Y'all are the only ones. What was the number you came up with? That's correct. Show everybody else or tell everybody else the route you went, okay? Good job. All right. Who was it that answered me last time? When the last time I was in here? What is it? Yeah, somebody else told me that in here too. Or was that you, Anthony? Okay. Yeah, you're right. That's the correct one. Tell everybody else in the group how you did it. Waiting for everybody to come back from the breakout rooms. All right, so looks like every group was able to come up with at least one person in every group was able to come up with it. So good job. Whoa, my thing disconnected. I'm gonna switch to the next slide so you can see one of the solutions. Um, and that's it right there. 2,455 is the solution to this problem. And uh, I told you there was only one solution, but there's actually two solutions. There's actually two ways to get this 2,455. The first way is the one you see there on the screen. Does anybody know what they think the other way is to do it? Yeah, just go the opposite way. Good job. Yeah, instead of going to Atlanta first, and you would go to LA first and go backwards. So this is just one of the ways, one of the two different ways to do the lowest cost, which is 2,455. Good job to those of you that figured that out and got that. All right, so almost done here. About 10 more minutes at the most. Let answer this question for me though. Let's see if you got this vocabulary down. What type of problem did we just solve? See, look at your screen there. You have two options. Let's get everybody to answer. 50-50 shot. Is it a Eulerian circuit or is it a Hamiltonian circuit? Which type of problem did we just solve in that particular problem, that traveling salesperson problem? Was it a Hamiltonian or was it a Eulerian? Put your answer there. Again, don't worry about being right or wrong here. Let's come up with a answer. Do it on your Pear Deck there. Don't put it on the screen, not in the chat, not in the chat. On your Pear Deck tab, either on your phone or whatever tab you have that on, you can answer it. Let's see what we come up with. Eulerian or Hamiltonian? I mean, 5 more seconds, guys. Let's get everybody to answer. Doesn't matter what you put. Don't worry about being wrong. 4, 3, 2, 1. I'm going to show you responses. Most of you picked the right answer. Yes. It is a Hamiltonian. Remember, we did not go on every flight. Every flight is the flights are the edges. We didn't do that. We went to just the cities. Those are the vertices. And so that's why it's a Hamiltonian there. Good job. So what you guys just learned about, or what you guys just saw, is a new type of graph. It's the only thing that we added were those numbers, the costs of those flights. So we call this a weighted graph. It's any graph whose edges are assigned a number value. And so weights could represent a number of things. The three most common things that they're going to represent are costs, like we just did right now. They're going to represent distance a lot of times, and sometimes they might represent time. So those are the things that you guys might represent with weighted graphs. And next week, you guys are going to do a project with these stuff. So this is kind of really important. That's going to be your first major grade. So I have two practice problems for you. This is going to take about 5 minutes. 5 minutes here. Bear with me. Stay with me here. The next slide, I have a kind of a scenario here. Has anybody ever been to a music festival before? I love festivals. Big on if you ACL. What is that one y'all like to go to? Jambalaya. What is that? Travis Scott Astroworld. When if you've ever been to a music festival, um, you know that there's stages set up all over the park or wherever it is that you're going to. So think of these vertices as stages at a music festival. And the numbers, the weights this time, they represent the number of minutes it takes to walk from one stage to another. They're like little paths between the stages. Draw on your screen, and you don't need to number anything out. Just draw on it real quick. What's the quickest way to get from stage C to stage D? Trace that path there. Trace it on your screen. The quickest way, not Lizzie, not the longest way. The quickest way to get from stage C to stage D. What's the quickest way? Just draw it real quick. Don't take too long on this. Let's get everybody participating. Draw the quickest way. Mia, that's a long way. Draw the quickest way, not the longest way. Same thing, Miranda. No, 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 no. I just want to get from stage C to stage D the fastest way possible. Don't use all the vertices. Yeah. Now we're not worried about all of them. We're just the quickest way to get from stage C to stage D. Let's see. Ooh, I'm tripping you guys up. Okay, this is good. All right. I don't think anybody's got a correct answer yet. And here's just watch. Don't change anything that you have. I have a lot of you guys are doing this. You're like, all right, started at C. I can go up. I can go over to D. That's pretty quick. 2 plus 7 is 9. So that's pretty fast. And even if I go the other way, C to E to D, 6 plus 3 is also 9. So it doesn't really matter which one. A lot of you picked both of those ways. But I'm trying to see if anybody picked the correct. I don't think I see a correct answer yet. You can't take a shortcut. You can't do this. Okay, you can't do that. Um, this is okay, guys. I'm kind of tricking you a little bit. Not really, but you got to pay attention to the numbers. Remember with that the problem that we just did. So if I started at C and I want to find the quickest way to D, the quickest way isn't always the most direct way to get there. Because if I go this way, 2 plus 3 plus 3 is only 8. And so that would be actually the quickest way to do this from C to E to B to D. So we got to be careful when we're looking at these weighted graphs because these weighted graphs are not to scale. We got to pay attention to the numbers. And so this would be the quickest way. It's not always the most direct. It's not the least number of edges. It is the least amount when I add up the weights on those edges. Okay, so don't get confused from that. Um, so one more practice problem. I guarantee you guys we're going to get 100% on this. Let's get 100% on this practice problem. Ready? What's the quickest way, the shortest route from A to E? What's the quickest route from A to E? Trace it on your screen. Let's get 100%. Adrian, come on. Think about it. Think about it. Think about what I just said. 100%. Let's get 100% on this. There we go, Mia. There we go, Faith, Leslie, Claudia, got it. Gus got it. Lizzie. Now you guys are figuring this out. Try again, Jose. Jillian. Good. I'm gonna go ahead and pop these up here. If you go directly from A to E, that's 7. But that's not the quickest way. This is the quickest way. This is the quickest way right here. From A to C, C to E, 3 plus 3 is only 6. Okay, so good job. You're able to see that and figure that out. So remember, quickest way, quickest path is not always the most direct. Okay, A to E directly seems like it's shorter, but that 7 is bigger than 3 and 3. Okay. Turn your cameras on for just a minute. I'm about to let you guys go, so turn your cameras on for just a minute.